You know how in the world of math we always learn brand new functions like the linear function, the quadratic function, let's say the exponential function, and after we learn what really the function like the symbols are, then we learn how to manipulate them, we learn how to solve equations with them, and then always at the very end we learn how to graph them. Well, guess what? Now that we're in the world of trig, we learned all about our six main cosine, sine, tangent, those functions. We've learned how to manipulate them through identities. We've learned how to solve equations with them. We learned all about this rotation system. Well, of course, the next logical step after that is, of course, to graph it. So that's what lesson 46 is all about, is learning how to graph the trig functions. And what I really want you guys to know more than anything is the fact of only with cosine x and sine x, I want you not only know how to graph the functions, but I want you to know how to actually transform the functions, which means, shifting left, right, up, down, all the stretching, reflecting, all of that. You only have to be able to do that with cosine and sine, okay? Everything else, like tangent, cotangent, cosecant, and secant, all you need to do is just be responsible to graph them in their basic form. So just graph y equals tangent x, just y equals cosecant x, okay? So just cosine and sine you have to know and be able to transform, and the other four you can just know just the basic form, okay? And I guess more than anything out of your notes, I just wanted to reiterate the fact of when you go to graph a function, it's mentioned this right in the paragraph above this, but look, all of your x values are always going to be angles. That's what you're plugging into your equation. And in other words, what you're doing is you're saying, okay, I want to rotate to this through this angle. I want to rotate up to like this degree, or I want to rotate up to this radians. In this first case, let's say pi over 2. And if I want to rotate when this down to negative pi over 2, since we're graphing the cosine function, it says, okay, when you take your radius and you go rotate all the way down to negative pi over 2, what's the x value you land at? Well, the x value is 0. Let's say at pi over 4, when you take that radius and you rotate up to pi over 4, what x value have you landed at? Well, it's the square root of 2 over 2, and since we're graphing, I kind of gave ourselves a decimal. Okay, so that's how you go about graphing these functions. And then the same thing if we come down here to cosecant. Well, I definitely replaced it as 1 over sine x, so we can look at that. Again, what you're plugging into the function is an angle. You're going, all right, I'm going to rotate to this angle, and once I get to that angle, I'm either going to pick off the y value, the x value of the coordinates, or ratios of the y's to x's, okay? And just, the really key trait about cosecant, tangent, secant, and cotangent is the fact of we have asymptotes. But hopefully y'all can go kind of slowly through the notes and just read what I have written down and make sense of those graphs. Okay? And like I said, all the transformations that we're going to do are just with sine and just with cosine. So whether I wrote sine right there or I wrote cosine right there with a bunch of this stuff inside, that it's all the same thing. We're going to transform only cosine and sine. And if you want to take 2 seconds and kind of look at what I wrote here, in this specific, it's kind of a summary of all the different transformations and where that you would normally see them. Alright, so it's plus or minus, like basically a number out front multiplied to your function, a number in here multiplied to x, a number added or subtracted after x, but still inside your function because it's inside those parentheses, and then a number in the back, either added or subtracted. And then I listed off the order. The first thing you look for is something that's causing you to go right or left with the function. And then you look for any kind of reflection that's going to reflect it over the y-axis. Then you look for any kind of number attached to your x variable, and that's going to be a horizontal stretch or compress. And we always take the opposite there. So if that b was, let's say, a 4, then we're going to multiply by 1/4. If that b was a 1/3, then we multiply by 3. Okay. Step 4 is the direct opposite. So what we want to do first is see, is there any number multiplied to our function on the outside? And that's going to be a vertical stretch. Then we need to see if we need to reflect over the x-axis, and then moving up and down. Okay, so let's go to our first example. In this first example, all we need to do is just list the transformations. We're not doing the graphing yet, we're just wanting to list them off. Okay, well, your options for, if I didn't say what the basic function was, like obviously I tell you right here, list off the transformations affecting cosine x, but if I didn't give you, your options are only going to be y equals cosine x, or y equals sine x. And obviously, since the word's cosine's written right in there, that's what we're going to be starting with. Okay, so we're going to start with y equals cosine x, and everything else that you see up there is going to be a transformation. We want to do it in order. Okay, first thing we notice is the plus pi. So I'm going to go right. I'm sorry, not right, because everything that's inside our function, we always have to do the opposite. So almost got myself there. We want to go left pi units. In other words, if we wanted to kind of write this out in words, we're going to subtract pi from the x values. Okay, and then just before I call any kind of horizontal movement done, I want to go back into this parentheses and see, is there anything else inside that parentheses that's unique? Well, there's nothing attached to the x, there's no negative inside and front, so really that's everything that's going to be affecting the x values. So now we're going to go to the outside, and on the outside, the order we go in is we first to look and see if there's anything multiplied to that function. Well, the 2 multiplied says that we have and this is going to be affecting our y's, so it's going to be vertical, a vertical stretch, which means we're going to multiply the y values by 2. Okay, 3 is the negative right there, and that's vertical movement, so we're going to reflect over the x-axis, which in short terms you can say we're going to switch signs on the y values. So we're going to go from quadrants 1 and 2, which are positive, to down to quadrants 3 and 4, which are negative, or vice versa. And then the last thing we're going to do is that last thing that's outside our function, we're going to shift down 1 unit. So that means subtracting 1 from the y values. All right. And that's all that this first example wanted us to do, was just to get practice recognizing all the transformations that are listed when you're looking at one function. So let's go down to example 2.